All right, IM3 classes. Today we're talking about graphing functions and transformations. It's three parts to this lesson. This first part, we're going to just look at some non-specific functions, graphs of functions, and practice moving them around and transforming them. And then we're going to work with specific parent functions for part 2 and part 3, and we'll get into those later. You'll be getting a packet in class. This packet, I'll be working through the problem. So everything you see here in this lesson is in the packet. If you are not in class, you can find this packet on Google Classroom. Anyways, there are 4 basic ways to transform the shape of a graph from its original function. There's a vertical translation or horizontal translation, and there's the vertical dilations or contractions in reflections, and horizontal dilations, contractions, and reflections. The vertical translation, this is, if you notice here, it says it's a shift. That is a, the graph is moved up or down. All right, so horizontal translation, that's what horizontal, that's mean it is just shifted left or right. A vertical dilation, contraction in the vertical direction, it is stretched. Shrunk, or the reflection is a flip. So that'd be a flip over the y-axis. Horizontal dilation is the same thing. It's a stretch. It's stretched, shrunk, or flipped. And that is over the x-axis. Excuse me, I have that backwards. The in the vertical direction is over the x-axis, is stretched away from the x. This one is over the y-axis. My mistake. There we go. We'll talk about it. But here's the thing with this. With most of these, you can get the same result from the vertical dilations. We really only deal with the vertical. So we don't have to worry about the horizontal dilations, contractions, and reflections. The vertical shifts and horizontal shifts, we'll be doing those. We'll be doing the vertical dilations, contractions, and reflections. We're not going to worry so much about the horizontal. All right, so moving on. So we have a graph here. This is our parent function, just a non-specific function. We're going to graph. Let's go ahead and practice labeling the points here. I know for a lot of you that this is the first lesson in the class. It's been a while since we've done something like this. Coordinates of this point here. So we go left 1, 2, 3, 4. So that x coordinate is -4. The y coordinate is up 1. So that's 1. So this one's at -4, 1. So this one's at -1, 1. So -1, 1. This next point here, that's to the right one. So that's a +1. And then it goes up 1, 2, 3. So +1, the y is +3. Over here to the right, it's 1, 2. So that's a +2 in the x direction. And then down 1, 2, 3, that's -3 in the y direction. So +2, -3. And then this last point is at 1, 2, 3, 4. So that's 4 in the x direction. Doesn't move up or down. So that's 0 in the y direction. 4, 0. What we do with translations and flips is we look at what's being done here. So notice the difference between these two here and then this function over here. They're both adding or subtracting some number to the function, but this is adding it outside of the parentheses, outside the grouping brackets or the function. This one's adding it inside the function. So this is going to be a vertical shift. We're going to shift this up 3. All right. So let's actually look at this. It's I think it's a little easier if you put the parent function in there real quick. So plot those. I'm going to plot those points real quick so we can see where the original points are. And then from each of these, I'm just going to go up 3 from each of these original points. So up 1, 2, 3. There's the new point. So up 1, 2, 3. Up 1, 2, 3. Up 1, 2, 3. Up 1, 2, 3. And so there is the shifted function up 3. All right. This one here is a shift down 2. So again, I'm going to put these quickly, sketch out the original, the parent function points here. And then from each of those points, I should connect it. I'm going to connect the dotted line for the parent function. Each of these I'm going to move down 2. So down 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And so there is my new function shifted down 2. Right here, we have this +1 inside the parentheses. This, when it's inside the parentheses, inside the function like that, that means it is a horizontal. Actually opposite from what the vertical shifts are. Since this is plus, normally you think that I'd shift it to the right. For the horizontal, this actually shifts it to the left one. The horizontal shifts are opposite. All right. And we'll go more into why that is in class. But for the purpose of this lesson, saving time on this video, I'm just going to tell you it's opposite, and we'll go over why that is in class. But so here's the parent function, sketch that out real quick. I'm just going to move each point to the left one. So left 1, left 1, left 1, left 1, left 1, and then connect the dots. All right. Let's look at next example. So this here, it's inside the parentheses. Let me move this down a little bit. It's inside the parentheses. So and it's minus, so it's opposite of what you would think. Normally you think minus would move to the left, so this moves to the right too. Real quick, I'm going to sketch out those points there. So here is the original parent function. And then for each of those, I'm going to go to the right too. So starting here, right 1, 2, 1, 2, 1, 2, here 1, 2, and 1, 2. Connect the dots. All right, this is where it can get a little tricky. On this, we are multiplying. When you're multiplying something on the outside of the function, that is going to be a stretch by a factor of 2. So let me plot the original points here real quick. So what you want to think for a stretch is, let's actually write that up here. It's a stretch by a factor of 2. What you want to think about a stretch is it moves the points, it multiplies the distance. Points are away from the x-axis, the horizontal axis, multiplies the distance they are from the x-axis by that factor. So here, you look here, this point is just 1 away from the x-axis. So that means the stretch, my new point needs to be double that. It's going to be 2 away, 1, 2. All right. So this point is 1 away from the x-axis. So my new point needs to be 2 away, 1, 2. All right. So this point here is 1, 2, 3 points away from the x-axis. So I double that. All right? So the new point needs to be 6, has a distance of 6 units away from the x-axis. It should be 1, 2, 3, 4, 5, 6. All right, so again, count how far. So this one is 1, 2, 3 points away. That means I double that. It's going to be 6. So 1, 2, 3, 4, 5, 6. And then this last point is on 0. So you double 0, you're still 0. So this stays where it's at. So the points just get further away. And that kind of got looking messy, didn't it? Shoot, I'm going to clean that up a little bit. Why not? So the original function, so if we look, so this one's 1 away, so this one needs to be 2. So this was up here, just putting the points back so it looks a little neater. There you go. So it stretches it out away from the x-axis. This one here, when it's a negative in front, the negative means you flip over the x-axis. So each point is just going to be reflected. This is a flip. So this point, it's 1 away from the x-axis. It needs to be 1 away on the other side. So here, 1 away needs to be 1 away on the other side. So this one is 3 away from the x-axis. I'm going to go 3 away on the other side. So this one is 1, 2, 3. So go 1, 2, 3. And then this is on it, so it stays right there. So it's going to look like this, just gets flipped over. Again, you count the distance, how far the point is from the x-axis, and your new point's going to be on the opposite side, same distance. And then the last one here, this is a shrink. Let's put the points where they belong. One half. So kind of like the stretch, the shrink just gets closer. So you're just multiplying how far these points are from the x-axis by this factor, and that's, you move it closer by that factor. So this point is 1 away, so the new point is just going to be half that distance. That's a weird little. So half the distance, half the distance. So this one is 1, 2, 3. Half of 3 is 1.5. So I need to go 1.5. So it's going to be right here. So this one, 1, 2, 3, 1.5 right there. Last point is there. So you just connect the dots so it squishes it down closer to the x-axis. All right, so basic formation. So we're going to be using this for all of it. So the vertical transformation. So if we have f of x, to shift it up, you add a value to the outside. We're going to call that value k. To shift it down, you're going to subtract a value from the outside of it. So we're going to subtract the value k. To shift it left, you are going to add a value. We're going to call the value h on the inside of the function. To shift it right, you are going to subtract value. All right, and then the stretch. You need to multiply by a value that looks really ugly. I apologize. And A needs to be greater than 1. Man, I'm having trouble writing with this thing today. Greater than 1. So if A is greater than 1, it shrinks or it stretches it. I should say absolute value of A is greater than 1. The shrink is if 0, if the absolute value of A, I'm putting absolute value because that if it's positive or negative, it doesn't affect if it stretches or shrinks. The absolute value of A needs to be in between 0 and 1. All right. For a flip happens when A, the value that you're multiplying by, is less than 0. All right. So basically, it's a whole number. If it's a number greater than 1, it's going to stretch it. What you want to look out for shrinks are fractions. Be careful with the fractions, though. The fractions do need to be between 0 and 1. It needs to be less than 1, greater than 0. And then anything that is negative, we'll flip it over the y-axis. Right. So let's just look at the parent function. What do each of these do? So just step by step, you look. Inside, you're subtracting, so that's going to be a shift to the right 1. And then we are adding 2, so that's a shift up 2. All right. And so that's really just all you need to do. We'll do a few of these. X minus 7, so that's going to be, remember that's opposite, so you think that'd be shift to the right, that's going to be shift to the left 7, plus 8 is going to be up 8. First thing, the 2, that's a stretch. We can just put stretch is fine, and then the minus 1 again is a shift to the right 1. All right, let's just do 2 more. The negative. So we have a negative, right? So that's a flip because it's negative. And then it's a stretch because that's a value greater than the multiplying by greater than 1. And then plus 3 on the outside is a shift up 2. So a flip, a stretch, a shift up 2. All right, this one, 1/2, that's going to be, the 1/2 is less than 1. So that is going to be a shrink. And then the minus 9 is outside the parentheses, so that is a shift down 9. I think that actually does it. Yeah, so that's the end of part 1. We'll start part 2 in the next video, but that'll be what we do for the first day of this unit. See you guys next time.